Ever pondered what causes the ground beneath your feet to shake suddenly? That's an earthquake. An earthquake is a natural phenomenon caused by a sudden slip on a fault. Imagine two giant tectonic plates, always moving, albeit slowly, but getting stuck at their edges due to friction. When the stress at these edges finally overcomes the friction, we get an earthquake. This event releases energy in waves that travel through the Earth's crust, causing the shaking that we feel. Take California as an example. Here, there are two significant plates, the Pacific Plate and the North American Plate. The Pacific Plate is made up mostly of the Pacific Ocean floor and the California coastline. In contrast, the North American Plate comprises most of the North American continent and parts of the Atlantic Ocean floor. Now, the primary boundary between these two plates is the San Andreas Fault, which is more than 650 miles long and extends to depths of at least 10 miles. This fault zone is also home to many smaller faults like the Hayward in Northern California and the San Jacinto in Southern California. The Pacific Plate grinds northwestward past the North American Plate at a rate of about 2 inches per year. Parts of the San Andreas Fault system adapt to this movement through a process known as creep, resulting in many tiny shocks and a few moderate earth tremors. However, in areas where creep isn't constant, strain can build up for hundreds of years, producing significant earthquakes when it finally releases. You see, earthquakes aren't just about the ground shaking. They're a complex interplay of geological forces, the movement of tectonic plates, and the release of energy that's been building up over time. And while they can be destructive, they're also a reminder of our planet's dynamic nature. So it's the slipping of fault lines and the movement of tectonic plates that cause the shaking we know as earthquakes. Now that you know what causes an earthquake, let's delve into some terms you might have heard: foreshocks and aftershocks. First up, foreshocks and aftershocks are both earthquakes, but they're defined by when they occur in relation to the main shock, the most powerful quake in a sequence. Foreshocks are aptly named because they come before the main shock. They're like nature's early warning system, but we can only identify them retrospectively once the main shock has occurred. Aftershocks, on the other hand, follow the main shock. They're typically smaller and gradually decrease in frequency over time, but they can still be mighty powerful and potentially damaging. Now let's debunk a popular myth. The position of the moon or planets, or whether it's morning or evening, has no significant impact on when earthquakes occur. Despite what you might have heard or read, earthquakes are equally likely to happen at any time of day or month. This is because earthquakes are caused by tectonic forces deep within the Earth, unaffected by celestial bodies or our human routines. They result from the release of stress that has built up over time due to the movement of tectonic plates. So don't be fooled by the myths. Earthquakes don't follow a schedule or respond to planetary alignments. They're a natural result of the dynamic planet we live on. Remember, an earthquake can strike at any time, and foreshocks or aftershocks are just part of the seismic process. Ever wondered about the depth at which earthquakes occur, or why we feel the shaking more at some places than others? Well, let's dive into it. Earthquakes occur in the crust or upper mantle, which ranges from the Earth's surface to about 500 miles deep. The strength of shaking from an earthquake diminishes with increasing distance from the earthquake's source. So, an earthquake occurring deep within the Earth will cause considerably less shaking at the surface than if the same earthquake had occurred closer to the surface. Now, what about surface faulting or surface rupture in an earthquake? This happens when movement on a fault deep within the Earth breaks through to the surface. But don't worry, not all earthquakes result in surface rupture. And why do we see so many earthquakes in the Geysers area in Northern California? Well, this region is tectonically active. The major seismic hazards come from large earthquakes occurring along regional faults located miles away from the geothermal field, such as the San Andreas and Healdsburg-Rogers Creek faults. Did you know that earthquakes also occur in Antarctica, although not very often? There have been some big ones, including one of magnitude 8.1 in the Bellini Islands, located between Antarctica and New Zealand. So there you have it. The depth of an earthquake and the geographical location play a key role in the impact it has on the surface.